Hi, I'm Kim Haynes, a Product Marketing Manager in the Chemistry Technology Center at Waters Corporation. In Part 4 of this series, we'd like to talk you through the calculations we used to evaluate our cleanup methods for recovery and matrix effects. It is important to understand how to do these calculations and how they are different from each other. Recovery calculations are done in sample matrix, while matrix effects calculations are done specifically to evaluate the effect of sample matrix on the recovery of the analyte.
To calculate recovery, there are two different solutions that you need to make: the post-extracted spike sample and the extracted sample. To make the post-extracted spike sample, you need to take a blank sample matrix with no analytes and then run that through your solid phase extraction procedure. At the end, you then spike your standards directly into that extracted matrix, and that creates your post-extracted spike sample. To create your extracted sample, you need to take your sample matrix once again, but actually spike your standards directly into that sample matrix. Then you run that through your solid phase extraction protocol and collect your eluate, which is now your extracted sample that contains your analytes. To do the actual calculation, you take the response of the extracted sample with the analytes and divide that by the response of the post-extracted spike sample, multiply that by 100, and that gives you your percent recovery. To effectively calculate matrix effects, we once again need two samples. Just like in recovery, we need a post-extracted spike sample, which we create by taking a blank sample matrix with no analytes. We run that through our solid phase extraction protocol, and then we spike our standards into that extracted matrix. This creates our post-extracted spike sample. Now, since we are evaluating matrix effects, it's important that we compare that post-extracted spike sample to a solution without matrix. So the second solution that we prepare is a standard solution that we spike the analytes into. So for example, if our post-extracted spike sample is in 75% acetonitrile and water, we want to make sure that our standard solution, where we spike our analytes into it, is also 75% acetonitrile and water. Now, to do the calculations to calculate matrix effects, we take the response of our post-extracted spike sample and divide that by the response of our standard solution. Then we subtract 1 and multiply that result by 100. That gives us our percent matrix effects. If we see a negative value for the percent matrix effects, we're seeing ion suppression. If we see a positive value, that means we're seeing ion enhancement.
We really hope this module helped talk you through the calculations we use to evaluate our cleanup methods for recovery and matrix effects. For more information about this or other related topics, you can always visit the Bioanalysis Bootcamp to learn more and increase your peptide and protein quantification fitness. Thank you.